welcome back to my next video on the chapter Real Numbers. This is for the standard 10. It's a very important topic which generally comes for the exams. Prove that root 2 is an irrational number. So here we are going to prove that root 2 is an irrational number using the theory of contradiction. So let us assume, so what we are going to do is, first we will assume, we have to prove it is an irrational number. So we will assume let root 2 be a rational number, and then we will do some steps, and finally at the result you will get a contradictory answer. So then we say what we have assumed is wrong. So let root 2 is rational number, is a rational number. If it is a rational number, any number, rational number can be expressed in the form of p by q. So therefore root 2 is equal to p by q, where p and q are positive integers, q not equal to, positive integers, and then p and q are co-prime. Co-prime means they have their HCF, their common factor, as 1. They will not have any other numbers as their factors. So co-prime means their HCF is 1. So this is a very important thing, because with this only we are going to prove it is irrational. So root 2 is equal to p by q. So we will square it now. Squaring. So root 2 the whole squared is equal to p squared by q squared. So it will become 2 is equal to p squared by q squared. So 2q squared is equal to p squared. So from this you can say p squared is equal to 2q squared. Therefore p squared, so any number you multiply by 2, it is even. So p squared is even. If p squared is even, then you can say p is even. Even means you have 2 as the 2 is a factor. Now if p is even, you can write p is equal to, any even number can be written as 2c, because the reason is p is even. This is 1. Now p squared is equal to, you can write this as 4c squared so c squared is equal to, now we will put in the place of p squared. So this is, so here I'll write this as 1 and this as 2. So substituting 1 in 3. So p squared is 2q squared. 2q squared is equal to 4c squared. So you will get from this q squared is equal to 2c squared. So earlier you got p squared is equal to 2q squared. Now q squared is equal to 2c squared. That means again q squared is equal to, therefore that means it is q squared is even. So from that you can say q is even. So that is 2 is a factor. So we got p is even, so 2 is a factor, and q is even. So from 1 and 1 and this is 4. So from 1 and 4, p and q are even. That means they have 2 as common factor. But our assumption is they do not have the p, but our assumption is P and Q are co-prime. Therefore, so it is wrong. So we have assumed it is co-prime, but we got P and Q are even. So our assumption is P and Q. So therefore our assumption is wrong, which is contradictory. So our assumption is wrong. Therefore, root 2 is irrational. Prove that root 5 is an irrational number. We are going to use the same method as what we did for root 2. So let us assume let root 5 be a rational number. So therefore root 5 is equal to, you can write it as P by Q, where P and Q are co-primes, are positive integers, and they are co-prime. Now squaring, you will get root 5 the whole squared is equal to P squared by Q squared. From that you get 5 is equal to P squared by Q squared. So 5 Q squared is equal to P squared. So from this you can say P squared has 5 as factor. So P has 5 as factor means P squared. So P also has 5 as factor. So this is 1. Or sorry, we will write this as 1 and this as 2. Now we will write let P is equal to PQ P by Q. So we will write P is equal to 5C. Since P has 5 as a factor, you can write P as 5C. So again squaring P squared is equal to 25C squared. Substitute now P squared is equal to 5Q squared. Substitute 1 in 3. We can write 5 P squared is 5Q squared. So 5Q squared is equal to 25C squared. So you can write Q squared is equal to, bring the 5 down, 5C squared. So again you get Q has 5 as factor. Q squared has 5 as factor. Therefore Q also has 5 as factor. So you have P has 5 as factor, Q also has 5 as factor. That is, so from P and Q have 5 as factor. This is from 2 and 4. Which is contradictory to our assumption P and Q are co-primes. Therefore, our assumption root 5 is rational number is wrong. Therefore, root 5 is irrational number. The same method only what we did for root 2. So first we have to take root 5 is p by q, and this is very important. You have to write they are positive integers and they are co-prime. Square it, and then you say p squared has 5 as a factor, p has 5 as a factor, and then you can write p as, since 5 is, you can write p as 5 into some other number. So p squared, then substitute that. So here we are trying to write p and q have common factor 5, and then proving that they are not co-prime.